Dear learner, I welcome you all to the program PG Certificate in Industrial Safety. I am Dr. Sanjay Agrawal, Associate Professor in Electrical Engineering, School of Engineering and Technology, Indira Gandhi National Open University, New Delhi. And I am also a program coordinator of this program. In this session, we will discuss basic of the electrical system. That is, we will discuss what is a conductor, what is an inductor, and we will also discuss type of the current like AC current, DC current. Then we will also understand what is the resistance, inductance, capacitance, and what is the function of coil and fuse. So after going through this module, you should be able to define electricity and various concepts related to the electricity. You will also able to differentiate about the conductor, insulator, voltage, current and resistance. So first of all, we are going to discuss what is electricity. Electricity is one of the most important blessings that science has given to the mankind. It has also become a part of the modern life and one cannot think of a world without it. Most people don't understand what it is. They just turn on a light, switch and there is a brightness, or start an appliance or push a button and something works. It is only when there is no electrical power there, then we start to consider the importance of electricity in our daily personal and working life. Although we cannot see electricity, but we are aware of it in our everyday life, there are countless ways in which we use it in our day-to-day activities. We cannot taste or smell electricity, but we can feel it. Electricity is defined as flow of electrons through a conductor. So now we are going to discuss what is electrical current. So when electrical potential difference is applied across two metallic wire, the loosely attached free electrons as shown in figure start drifting towards the positive terminal of the cell as shown in figure. This continuous drifting of the electrons constitute the electric current. Therefore, a continuous drifting of electron in an electric circuit is called electric current. The drifting of electrons in the wire is from B to A, as you can see in the figure, that is from negative terminal of the cell to the positive terminal through the external circuit. The conventional direction of flow of current is from A to B, that is from positive terminal of cell to the negative terminal through the external circuit. The magnitude of flow of current at any section of the conductor is the rate of flow of electron, that is charge flowing per second. It can be expressed mathematically as current I is equal to Q upon T, where this I is a current, Q is a charge and T is a time. And unit, since charge is measured in coulomb and time is in second, so unit of electric current is coulomb per second, or you can say ampere. So ampere is equal to what? Coulomb per second. Now we are going to define what is a voltage. The electromotive force or potential difference causing the flow of electrons, or you can say current, in any conductor is called voltage. The voltage is measured between the two ends of the circuit, and basic unit of voltage is volt, and generally it is denoted by capital V. The waveform of the voltage available from household electrical power socket and from the terminal of the dry cell in your pocket calculator are shown in figure. Here you can see that on the vertical axis voltage has been shown, and on the horizontal axis time in millisecond has been shown. So here you can see the current. If we are talking about the AC current, so it start from 0, then positive maximum, then it comes positive maximum to again 0, then 0 to again negative maximum, and from negative maximum to again 0. So when it goes from 0 to maximum, then 0, then 0 to negative maximum, then 0. So one cycle is complete. If we are talking about the DC current, so magnitude of the current is always constant with respect to the time. That means polarity of voltage does not change with respect to the time in case of the DC current. Now we have to define electrical circuit. The electrical circuit are closed loop or path which forms a network of electrical component where electrons are able to flow. This path is made using electrical wire, or you can say conductor, and is powered by a source like a battery. The start of the point from where the electron start flowing is called the source, whereas the point where the electrons leave the terminal is called the return path. Now, as I already told you that there are different elements associated in the electrical circuit like resistance, inductance and capacitance. So one by one we are going to define what is the resistance and inductance and capacitance. So first of all we are going to discuss what is resistance. Resistance is the property of substance which gives opposition to flow of electrons through itself. If we apply same voltage to the ends of different material, the amount of current that flows will differ in each case. So resistance is the property that causes this difference. Higher the resistance, lesser would be the current, because I is equal to V upon R, or you can say current is inversely proportional to the resistance, because in generals metal have less resistance and hence are suitable as conductor of electricity. The most common conductor are copper and aluminum. Now there are laws of the resistance. So the resistance R of a wire depends on the following factor. What is those factor? First factor, it is directly proportional to the length of the wire. That means R is directly proportional to the length of the wire. Second is, it is inversely proportional to its area of cross sectional. If area of cross section is A, then you can write R is inversely proportional to 1 upon A, where A is a cross sectional area and R is the resistance of the conductor. Resistance depend upon the nature, that is atomic structure of the material of which wire is made. It also depends upon the temperature of the wire. Neglecting the last factor for the time being, we can write R is proportional to L upon A, or you can write R is equal to rho L upon A, where rho is a constant and it is called resistivity of the wire, and this value depends upon the nature, that is atomic structure of the wire material, representing the third factor earlier. Now we are going to define the conductance. The ease to flow of current is called conductance. It is generally denoted by letter capital G. We know that opposition to the flow of current is called resistance. Hence conductance is just reciprocal of resistance. So you can write G, that is a conductance, is equal to 1 upon R, that is resistance, or you can write G equal to 1 into A upon rho L, or you can write G is equal to sigma A upon L, and unit of conductance is denoted by mho, and symbol is just reciprocal of ohm. Now we are going to define conductivity. From the expression given earlier, sigma is called the conductivity or specific conductance of the material. It is basically the property or nature of the material due to which it allows the current to flow through it. So as you know, Z is equal to sigma A upon L. So you can write sigma is equal to what? You can write sigma is equal to GL upon A. So substituting the unit of various quantities, we get sigma is equal to mho into meter upon meter square. So we get sigma is equal to mho per meter. Hence the unit of conductivity in SI unit is mho per meter. Now we are going to define Ohm's law. So Ohm's law states that current flowing between any 2 points of the conductor is directly proportional to the potential difference across them as shown in figure, provided physical conditions are kept constant. And what are those physical conditions? That is a pressure, or you can say temperature. So mathematically we can write I is proportional to V, or you can write V upon I is equal to constant. So you can write V1 upon I1 is equal to V2 upon I2, or V3 upon I3 is equal to constant. That means ratio of voltage and current is constant. And so what is this constant? This constant is nothing, it is a basically resistance. So in other words, Ohm's law can also be stated as follows: the ratio of potential difference across any two points of conductor to the current flowing between them is always constant, provided the physical condition, that is temperature, etc., do not change. This constant is called resistance of the conductor. So V upon I is equal to R. It can also be written as V equal to IR, or you can write I equal to V upon R. In a circuit, when current flows through a resistor, the potential difference across the resistor is known as voltage drop across it, that is V is equal to I into R. So whenever any current is flowing through the resistance, that current is I and the resistance of that wire is R. So whatever the voltage drop is occurring across that particular resistance, you can write V is equal to I into R. So there are some limitations of the Ohm's law. Ohm's law is not applicable for unilateral electrical element like diodes and transistor, as they allow the current to flow through in one direction only. For non-linear electrical element with parameter like capacitance, inductance, etc., the voltage and current would not be constant with respect to the time, making it difficult to use Ohm's law. So these are the limitations of the Ohm's law. Now there are different applications of the Ohm's law to determine the voltage, resistance or current of an electrical circuit. Ohm's law is used to maintain the desired voltage drop across the electronic component. Ohm's law is also used in DC ammeter and DC shunt to divert the current. Here you can see by this triangle, VIR triangle. So just for remembering what will be the formula of the voltage, current, resistance. So here you can see we can write V is equal to I into R, and with the second triangle here you can see it is showing that I is equal to V upon R. Similarly, R is equal to V upon I. Now we have to define the electrical power, right? So if you are purchasing any appliances, generally it is defined by the power. So we have to understand what is the electrical power. So power is the rate of doing work. In case of electricity, we define it as product of voltage and current. So power is used to produce real work. So measuring unit of power is joule per second, or you can say watt. So as you know, as I already told you, that power is a product of voltage and current. So you can write P equal to V into I. Suppose we are writing power is equal to 1 watt. So if 1 voltage is applied and 1 ampere current is flowing, then you can say 1 watt power is being generated. And bigger unit of power is a kilowatt. So 1 kilowatt can be written is equal to 1000 watt. Similarly, 1000 kilowatt can be written is equal to 1 megawatt. So for remembering the formula of the power, here again you can remember the formula of the power with this power triangle. So here you can see with from the first triangle P is equal to I into V, and from the second triangle here you can see that I is equal to P upon V. Similarly, from the third triangle here you can see V is equal to P upon I, where P is a power and I is current. Now we have defined the current, voltage, power. Now we have to define the electrical energy. So what is the electrical energy? The capacity for doing the work is called the energy. To say it differently, it is the rate of doing work multiplied by the time for which power is applicable. So measuring unit of electrical power is kilowatt hour, or you can say 1 unit of electrical energy means 1 kilowatt hour. So energy is what? Energy is nothing, it is a product of voltage multiplied by time. So if you are using 1 kilowatt power for 1 hour, that means you are consuming 1 unit of electrical energy. So you can write 1 kilowatt hour is equal to what? 1 kilowatt for 1 hour, or you can say 1000 watt for 1 hour, or you can say 36 multiplied by 10 to the power 5 joule. So 1 kilowatt hour is equal to 1 unit of electrical energy. So whatever the electricity bill that you receive in your home, always electrical energy is defined in unit. So if you are consuming 1 unit of electrical energy, that means you are using 1 kilowatt hour. So it is also known as Board of Trade unit, that is BOT. So larger unit is called megawatt hour, which is equivalent to 1000 kilowatt hour. Now we are going to define what is a inductance. Inductance is that property of the coil by virtue of which an EMF is induced in the coil when the magnetic flux linked with the coil is changed. The change of flux may be due to changing current, or you can say alternating current. So the measuring unit of inductance is what? The measuring unit of inductance is Henry, and it is denoted by the capital L. So you can define V is directly proportional to di over dt. So you can write V is equal to L di over dt, or you can write L is equal to V upon di over dt. So di over dt is what? It is a rate of change of current, and V is a voltage applied. The current I that flows through an inductor produces a magnetic flux that is proportional to it. An inductor opposes the rate of change of current flowing through it due to the buildup of self-induced energy within its magnetic field. Now we are going to define inductive reactance. So inductance has already been defined. Now we have to understand what is inductive reactance. Effective opposition offered by inductance is called inductive reactance, and it is denoted by XL, and XL can be written as omega L, and omega can be written as 2 pi F. So XL can be written as 2 pi FL, where this F is a frequency and L is the inductance. So the combination of 2 pi F is often replaced by the omega. So it is written as XL is equal to omega L. Because it is a inductive reactance, reactance is also opposing the flow of current. So unit of inductive reactance is again it is ohm. Now we are going to define the capacitance. The capacitor is the component which has the ability or capacity to store energy in form of an electrical charge, producing a potential difference across its plates, much like a small rechargeable battery. Here you can see in the figure, also voltage is applied across the two plates, and here you can see between the two plates there is a dielectric. So the capacitance can be written as ratio of charge and voltage. So you can write C is equal to Q upon B, and I can be written as dq over dt. So this Q can be replaced by the Cv. So you will write I is equal to dCv over dt, or you can write current flowing through this capacitor I can be written as C multiplied by dV over dt, and measuring unit of capacitance is a farad. Again, for remembering the formula of formula for the Q, here you can see from the triangle Q can be written as C multiplied by V. C can be written as C is equal to Q upon B, and from the third triangle here you can see V is equal to Q upon C, where Q is a charge and C is a capacitance. Now again we have to understand the capacitive reactance. Effective opposition offered by capacitance is called the capacitive reactance, and it is denoted by X suffix C, and it is equal to 1 upon 2 pi Fc. So Xc is equal to what? Xc is equal to 1 upon 2 pi Fc, where F is a frequency and C is capacitance. Again, to this 2 pi F can be written as omega. So Xc can be written as 1 upon omega C. Now we have understood resistance, we have understood the inductive reactance, we have understood capacitive reactance. So another term is coming, impedance. So impedance is what? Impedance is nothing. It is the total opposition offered by series circuit containing resistance, inductance and capacitance is called impedance, and it is denoted by capital Z, where Z is equal to what? Z can be written as R plus Jx, where this R is a resistance and this X is a equivalent reactance, means combination of inductive reactance and capacitive reactance. So in this X denotes the reactance due to the inductance or capacitance or combination of both. R is the resistance and J is the symbolic representation of square root of -1. This is called imaginary number and is used in the calculation of the complex equation in relation to the electricity. Using this representation of the impedance, the associated current also has two components, that is real and imaginary, or active and reactive. We will deal with this in the next section. Now we have to see there is a three type of electrical load. Devices that are connected to the power system are referred to as electrical load. The three types of load are resistive, inductive and capacitive. So what is a resistive load? Units of electrical power associated with the resistive load are what? Light bulb, toaster, electric hot water heater and so on are the example of the resistive load. Inductive load. Inductive load require magnetic field to operate. All electrical load that have a coil of a wire to produce magnetic field are called inductive load. Example of electric loads are hair dryer, fans, blender, vacuum cleaner and many of other motorized devices. The unit of inductance are Henry, as I already told you. Now we have to see what are the capacitive load. A capacitor is a device made of two metal conductors separated by an insulator called dielectric, that is a air, paper, glass and other non-conductive material. Dielectric material become charged when voltage is applied to the attached conductor. Capacitor can remain charged long after the voltage source has been removed. Example of capacitive load are TV picture tubes, long extension cord and component used in the electronic devices. Now we have to define what is a conductor. So conductor are the material or substances which allow electricity to flow through them. They are able to conduct electricity because they allow electrons to flow inside them very easily. Conductor have this property of allowing the transition of heat or light from one source to another. Metals, humans, earth and animals' bodies are all the example of the conductor. This is the reason we get electrical shock. The main reason is that being a good conductor, our human body allows the resistance free path for the current to flow from wire to our body. Conductors have free electron on its surface which allows current to pass through. This is the reason why conductors are able to conduct electricity. Now we have to see what are the examples of the conductor. So silver is the best conductor of the electricity. However, it is costly and so we don't use silver in industries and transmission of the electricity. Copper, brass, steel and aluminum are good conductor of electricity. We use them mostly in the electrical circuit and system in form of the wire. So generally the binding of the motor are made of the copper, and if you are able to see the ACSR conductor that is used for the transmission, that is called aluminum conductor steel reinforced. That means this conductor have aluminum as well as steel. Basically the function of steel is to give the mechanical support and aluminum is used as a conductor for the transmission of the electricity. Mercury is also an excellent liquid conductor that finds use in many instruments. Gases are not good conductor of electricity as the particles of the matter are quite far away and thus they are unable to conduct electrons. Now we have to see what is an insulator. Insulator are the materials or the substances which resist or don't allow the current to flow through them. They are mostly solid in nature and are finding use in variety of the system. The property which makes insulator different from conductor is its resistivity. Wood, clothes, glass, mica and quartz are some good example of the insulator. Insulator are also protectors as they give protection against heat, sound and of course the passage of the electricity. Inductors don't have free electrons, and it is the main reason why they don't conduct electricity. Now we have to see what are the examples of the insulator. So glass is the best insulator as it has the highest resistivity. Plastic is also a good insulator, and it's fine it used in making a number of things. Rubber is the common component in making tires, fire resistance clothes and slippers. This is because it is a very good insulator. Now we have to see what is the current. So current can be classified as AC current and DC current, as I already discussed about this AC current and DC currents. So alternating current can be defined as a current that changes its magnitude and polarity at regular interval of time. It can also be defined as an electrical current which repeatedly change or reverts its direction opposite to that of direct current, or you can say DC, which always flows in single direction. Basically AC is used to deliver power to industries, house, office, building, etc. So from the graph we can see that charge particle in AC tend to start moving from zero. It increases to maximum and then decrease back to zero, completing one positive cycle. The particle that reverse their direction and reach the maximum in the opposite direction, after which AC again returns to its original value, completing a negative cycle. The same cycle is repeated again and again. Alternating current are also accompanied usually by the alternating voltages. Besides, the alternating current is also easily transformed from a higher voltage level to lower voltage level. Now we have to understand what is a DC current, or you can say direct current. So DC is the movement of electric charge carrier, that is electrons in unidirectional flows as shown in figure. In a DC, the intensity of current will vary along with the time, but the direction of movement stays the same in all the time. Here DC is referred to as voltage whose polarity never reverse. Now we have to again understand what is a coil. An electromagnetic coil is an electrical conductor such as wire in shape of the coil, spiral or helix as shown in the figure. Electromagnetic coil are used in electrical engineering where electrical circuit interact with the magnetic field. The last term that we have to understand here, that is a fuse. So you are very familiar with the term of the fuse. So what is a fuse? A fuse is an essential device used in various electrical circuit which gives the protection from the overcurrent. It comprises a strip or a metal wire that dissolve when the flow of current supplies through it. Once this device has functioned in open circuit, it ought to rewire or change based on the type of the fuse. Fuses are used to prevent the home appliances from the high current or overload damage. If we use fuse in a homes, the electrical fault cannot happen in the wiring and it does not damage the appliances from the fire of the wire burning. When the fuse gets break or damaged, then an abrupt sparkle happens which may direct to damage your home appliances. That is the reason we require different type of fuses to guard our home appliances against damage. So dear learner, in today's session we discussed what is electricity, type of current, that is alternating current and direct current. Then we discussed basic of the electrical system, like what is the resistance, inductance, capacitance, what is the inductive reactance, what is the inductive capacitance. Then we also discussed the function of the coil and fuse in this particular session. Hope you are able to grasp all the topics in good manner. Thank you very much.